So welcome all of you. In this video, I will explain the phasing strategy in CNC milling machine. First of all, I will open this model. So from the CAM samples workspace, I will double click on this. From the CAM samples folder, I will double click on this tutorial 1. The first step is you have to create your own model. So here this is one sample example. So this is already in this folder, CAM samples. Go to the CAM samples, then double click on this tutorials, and here you can see tutorial 1. Okay, I will open this. Then I will go to the manufacturer workspace. Okay, so I will change the design workspace to manufacturer workspace, and then I will select the milling 2D phase. So I will select the phase strategy. Okay, so I will select the phase strategy now the next step is you have to select the tool. Okay, so I will click this select option. I will click the select option, and from this tutorial metric, I will double click on this tutorial metric. So here the tools in the central portion, we can see the tools are displayed 20, 21, 22. These are the tool numbers, and their diameter is given 10 mm diameter, 6 mm diameter, 3 mm, etc. etc. So in the right side there is a filter option, the type. You have to select the phase mill. So click this phase mill option. Now in the central portion there will be only one tool, that is the phase mill, and the tool number is 1. This is tool number 1 and 50 mm diameter phase mill. Okay, I will click this. That means you have to select this phase mill, and then in the bottom there is an option that is called a select. Click on this select button. So here in the tool you can see #1 that represents tool number 1. This is tool number 1. Now number of the tool is 1, and the diameter 50 mm, 50 mm diameter face. So that is displayed in the screen, and we can see the tool. This is the tool, and this is the stock, or this is the part, and this tool is perpendicular to the XY plane. That means in the Z axis. Then I will not change any speed feed values. Okay, so here the spindle speed is given as 955 RPM, and the feed rate is given as 460 millimeter per minute. So spindle speed is given as 955 rpm and the feed rate is given as 460 millimeter per minute. So I will not change this value, the same default value. And then next is I will select the geometry. So when I will click the geometry, see, this is the boundary. Inside this boundary, we have to face this. Facing means we have to remove the material from the top surface. That means we have to flatten this surface. So this boundary, inside this boundary, we have to we have to face this. So when I will click the geometry, it will automatically select the boundary. Okay, nothing to select. Okay, no boundary to select. Automatically, in the facing strategy, automatically this will select the outer boundary based on our model, based on our stock, or based on the model we have created. Then go to then all other values, default values. We will not change any values. Okay, so then I will click OK. I will click OK. Okay, now we can see this tool. The stock with tool path is displayed. This line represents the tool path. This line represents the tool path. So here we can see a red arrow. Okay, so this is the starting point. This red arrow, this represents the starting point, and there will be a green arrow. This represents the end point. Okay, and this blue line represents the cutting. Okay, so this is the tool path. This is the tool path. This is the tool path. So here you can see this is the tool. Okay, and this is the tool, and this is the stock or model, and this line represents the tool path. So everything is displayed. Then the next step is you have to, okay, so here in the browser, in the left browser, we can see here this is the T1. So T1 means tool number 1. Tool number 1, and the strategy is facing strategy. Okay, then if you want to know the toolpath, if you want to show the toolpath data, just right click here, and then here there is an option that is called show toolpath data. Okay, so show toolpath data. So this is the toolpath data, and here you can see the total 14 movements are there. So the first one is the this is the linear movement, then this is the linear movement, and then this is the linear movement. Then there will be a circular movement. Okay, then after that there will be a linear movement. Okay, then after that the blue line, this blue line represents the cutting. Okay, and then after that there will be an arc, that is the circular movement. Okay, this is the circular movement. Then the next will be linear. Okay, then again there will be a circular movement. Then the linear, that this blue line represents the cutting, I already explained. Okay, then the next circular interpolation, then next is linear, and then after that there will be a circular movement. Okay, and there will be a final linear movement. Okay, so this is the toolpath data, and here you can see the feed rate. Okay, sorry. Yeah, here here you can see the feed rate is given. Feed rate is given as 460 millimeter per minute. So feed rate is given as 460 millimeter per minute, and the RPM, okay, and the RPM, okay. So here, what is the RPM? RPM given as 955, okay, 955 RPM. Okay, I will close this. Okay, once again, I will right click here and edit. Okay, and here you can see the spindle speed. The spindle speed is given as 955 RPM, and the feed rate is given as 460 millimeter per minute. Okay, 460 millimeter per minute. Okay, I will right click here, show toolpath data. So the feed rate, feed rate is given as 460 millimeter per minute, and the RPM is the spindle speed. RPM is 955 RPM. And this blue line, this is the cutting. Okay, so this is the first cutting. Then this is, sorry, 1 minute. Okay, so this is the first cutting. Then next is this one, then this one. Okay, so 1 2 3 4, so four movements, 4 cutting movements. Okay, 4 cutting movements. Remember, this blue line represents the cutting. Okay, so everything is okay. Then go to actions tab, then click this generate toolpath, then click yes, then go to the simulate. Next is the simulate option. Okay, when you select this simulate option, we can see the first thing is related to the tool. Okay, so this is the tool, and then the second is the tool path. Okay, this line, this is called tool path, and this stock, and this is our stock. So you can adjust the view, you can adjust various things related to the tool, related to the stock, related to the tool path, with the help of this options. And finally, there is an option called view. So there are two options: model option and tool option. So model option means, so I will show you the two options: model option and tool options. Why simulated? Okay. Then I will select the first option, that is tool. Okay, so if I will select this float option, then the display will be, the tool display will be float only. Then if I will select the shaft option, there will be float, then shaft. Then if I will select, there will be float, shaft, and the holder option. So we can change the tool options: float, the shaft, the holder, with the help of this option. Okay, then if you select this transparent, this will become transparent. Here you can see the tool will become transparent, or I will uncheck this. Okay, that will be off, transparency will be off. Then here the programmed point is displayed here. If you want to uncheck this programmed point, just click here. Okay, so I will click this programmed point. So that is related to the tool. Then next is related to the tool path. Okay, so tool path means this. Okay, so tool path means this line. Okay, this is the tool path. Okay, and if you want to various options like all tool path means everything is displayed. That means the starting point, the cutting, the leading, everything will be displayed here. That is all tool path. The tool path before position means that means the tool path before position is displayed. So tool path after position, you can see after position is displayed. Then toolpath for operation, then that will be displayed. Then tail will be displayed. Okay, so here I will select the all toolpath, so all toolpath will be displayed. Then if you want to show the points here, these are the points. Okay, these are the points. Okay, if you want to show points, click here. Or if I will uncheck this, we can see that is not displayed here. Okay, show points. With the help of this show points, we can check or uncheck. Then the cutting moment will be this blue line. If you want to, if I will select this, you can see that blue line is not displayed here. That means that cutting movement is not displayed here. With the help of this, we can control. Also the leads. Okay, here this is the lead. Okay, we can show the leads. Okay, this is the lead. Okay, we can control the display of this lead with the help of this box. Okay, then this links. Okay, so these are the links. Okay, we can control the display with the help of this links. Okay, so points, then cutting move, then leads and links. We can adjust the toolpath with the help of this toolpath. Then next is the stock. Okay, so I will click here. Now this is my stock. Where if I will uncheck this, what happens? This is the final model I want to get. Okay, so that means after machining I will get this. So that is the model. Okay, so if I will select this stock means that original workpiece. So this is our stock. Okay, so we can adjust the various display details related to this stock with the help of this. Okay, colorization using material for operation, then tool comparison, etc. Okay, with the help of this, and we can set the accuracy. Okay, the accuracy means the accuracy of the stock. We can choose a higher accuracy at the expense of slower generation time. So higher accuracy means the generation time will be slower. Okay, then transparent means again similar to this the tool transparency. The stock will be transparent. Okay, so I will uncheck this. Stop on collision means that will be automatically stop. The tool will automatically stop. There will be a collision. Enable to force the simulation to stop if a collision or gauge is detected. Okay, then I will click this view as model option. Then I will click the play button. Now you can see this is the phasing operation. The stock is fixed and this tool is moving. Okay, then circular interpolation, then linear interpolation. Then after that, here there will be a circular interpolation. Then there will be a linear interpolation. That means the cutting, phasing. You can see the top, flatten the top is happening. Then there will be a circular interpolation, and there will be a linear interpolation. That is the cutting. And finally moving to the back. Okay, so this is the viewpoint model option. So if I will select this tool option, what happens is the tool is fixed and this stock is moving. Okay, so here you can see the tool is fixed and this stock is moving. That is the tool option. Okay, so that is the tool option. So I will again go back to the model option. Okay, that means the stock is fixed and this tool is moving. Okay, so I will close this, then go to actions. So now everything is correct. Okay, so if everything is correct, you want to protect this strategy, you can right click here and you can use this protect. That means then after that you can't. Okay, okay, if then after protect, after enabling this protect option, if I want to edit this tool, I can't edit. Okay, you may not edit a protected operation. Okay, so this is everything is correct, that is protected. Okay, so here you can see this checkbox. That means the protect option is enabled. Then go to actions, then post process. Then I will select the Fanuc controller and then I will click the post button and click S. Now this NC code is generated. Okay, so now the NC code is generated. Okay, so this is the NC code. Yeah, this is the NC code here. Here, this is the NC code for Fanuc controller. So Fanuc controller. Okay, so the starting symbol, this is the percentage symbol, and this is the program number. This is the program number, and here tool number 1, and the diameter is 50 and face mill. Then after that you can see G90. G90 means absolute positioning. There will be two positioning, absolute positioning and incremental positioning. So G90 selected, that means absolute positioning. Then G94, G94, that means feed rate per minute. Okay, so I have already given the feed rate as 460 millimeter per minute. Okay, so G94 means feed rate per minute. Then next is the G17. Okay, G17 means plane selection. The phasing operation will be in the XY plane. So XY plane, select the XY plane. That means G17 XY plane selection. And then G49. G49 means this G49 and this G80. G49 means tool height, tool length compensation cancel. Tool length compensation cancel. And also G80 means canned cycle cancel. Canned cycle cancel. So this is tool length offset compensation cancel, and this G80 means canned cycle cancel. So these two are, one is length compensation cancel and this is canned cycle cancel. Then next is G21. G21 means that is programming in millimeters. We are using millimeters. Okay, programming in millimeters. Then next is the G28. So G28 means go to the recorded origin point in the machine coordinate workspace. Okay, the tool will move to the, there will be a recorded origin point. The tool will move to the recorded origin point. That is the G28. Then next is the phasing. So these are the header. Then next is the phasing. This is the phasing operation. This is the phasing operation. Okay. Then the first line is M06. M06 means tool change. We have to select the tool change. M06 tool change to T1. So T1 is the tool, phasing tool. Here tool number 1 is the phasing tool. So tool change into T1. Then S means 955 RPM, spindle speed 955 RPM, and M03 means clockwise direction. Okay, spindle clockwise direction, clockwise rotation M03. Then next is the M08. M08 means coolant on. Okay, so before starting the phasing, we have to start the coolant on. So M08 means coolant on. M08 means coolant on. Okay. Then next is the G00. G00 means the rapid movement. G00 means the rapid movement, G00, G00 rapid movement to the coordinates is given, X value and Y value is given. Then next is the G43, next is G43. G43 means tool height compensation. Tool height compensation. Okay, so we have to compensate the tool height. And G43 we can see H01. H01 is the compensation value. Compensation value. Okay, which compensation? The H value. The H value tells the machine control software which compensation value to apply. Then next is the G00, again a rapid movement. Then G01 linear interpolation. G01 linear interpolation, linear movement. Okay, and here you can see the feed is given. Feed is 460 millimeter per minute. Then next is the G18. G18 means the XZ plane selection. Okay, in the XZ plane there will be a G03 movement. G03 movement means the circular interpolation in the counterclockwise direction. Circular interpolation in the counterclockwise direction, that is G03. Then next is G01 linear interpolation. Then G17, G18 XZ. Then G17 means XY plane. Okay, coming back to the XY plane, G17 XY plane, there will be a G02 circular interpolation clockwise direction. There will be a G02 movement, circular interpolation in the clockwise direction. Then G01 linear interpolation. Then G03 circular interpolation counterclockwise. G01 linear interpolation. Then G02 there will be a circular interpolation in the clockwise direction. G01 that is linear interpolation. Then G18 means in the XZ plane there will be a G02 movement, circular interpolation in the clockwise movement, G02, and the G00 linear rapid movement. And then G17 means again the XY plane selection. So the phasing operation is completed. Then the last footer. Okay, footer means, so once the operation is completed we have to M09 coolant off. Okay, so okay, 1 minute. Okay, so M08. Okay, so M08, so this is M08. Okay, M08 coolant on, and after the phasing operation M09 coolant off. Then again G28 means go to the recorded origin point in the machine coordinate workspace. Then next is the G49, that means cancel. G49 means tool length compensation cancel. Then G90, that means absolute positioning. And finally M30 means program, end of the program. Okay, end of the program. Okay, so here there will be various codes related to the rapid movement, then the cutting, that means cutting with the feed rate, then circular interpolations in clockwise direction or in counterclockwise direction. Then various types of plane selections, that is again important, whether it is XY plane, whether it is XZ plane. Okay, plane selection. Then coolant on, coolant off. Okay, then tool selection. Okay, everything. So everything will be will be expressed as a program. So this is called the CNC program. Okay, so this is a simple CNC programming related to the phasing operation, phasing strategy in milling machine. Okay, so once again I will show the toolpath again. Okay, so I will. Okay, so here you can see this is the toolpath. Okay, so here this is the toolpath. Okay, here this is the toolpath. There will be a linear interpolation. Okay, so there will be a linear movement. Then there will be an arc, that means circular interpolation. Then there will be a linear movement. Then there will be an arc, that means circular interpolation. Then there will be a linear movement. Then there will be arc, circular interpolation. Then there will be linear movement. There will be arc, that means circular interpolation. Then there will be again linear movement. Then there will be an arc, circular interpolation. Then linear interpolation. Okay, so there will be G0, G01, G02, G03, etc., etc., etc. Okay, if you want to see the toolpath data, right click here and this show toolpath data. We can see this various motions. Okay, okay, okay. So here you can see the various motions. This is the linear. Okay, G01, maybe the G01 linear, G01 or G00, then G02 or G03, circular interpolation, G02, G03, then G01, then linear G01, circular interpolation, G02 or G03, linear G01, then circular G02 or G03, then circular linear G01 or G02, then circular G02 or G03, then linear G01, then circular G02 or G03, and finally linear G01 or G00. Okay, so and finally so the code is generated, and finally go to actions, then finally go to the setup sheet. Okay, okay, so this is the setup sheet. Okay, so the setup sheet means everything related to the stock. Okay, so this is the stock. Okay, and the part. Okay, then the total number of operations. So here only one operations and only one tool is used, and the tool number is T1, and the feed rate is 460 millimeter per minute, and the spindle speed is given as 955 RPM, and the cutting distance, the rapid distance, estimated cycle time, everything is displayed here. And then the next is, after this total we can see two options. One is tool. So here the details related to the tool. So this is my face mill, and the diameter is given 50 mm, and length is given 50 mm, and flute is 4. So the feed is 460 millimeter per minute. Maximum spindle speed is 955 RPM. Then after the tool we can see the operations. Only one operation, that is the phasing strategy. We are using the phasing strategy. Everything is displayed here related to this operations. The maximum spindle speed 955 RPM, maximum feed rate 460 millimeter per minute. Okay, so this sheet is everything related to the tool, the operations, the stock, everything. That particular sheet is called a setup sheet. Okay, so once you have simulated this, so once you have completed this, once you have completed this, here go to actions, then first you generate, then after that simulate, simulate. Simulate means you have to check the path, everything is correct or not. Then the next step is the post process. Post process means you are converting this into a particular code that will be suitable for your CNC machine, and then you have to generate the setup sheet. Okay, so do this and generate the CNC code. Thank you.